It's camera.
Go.
Okay. Thank you, Saul. Complex numbers. On Friday, we talked in more detail than you actually need about where complex numbers come from. Gentlemen, pull it together, please. Thank you. And we talked about why the square root of -1 has to exist on a complex plane where it does.
Wait, did you talk about that name Wallace?
Yes, I didn't mention his name this time though. With good memory. So this is where on an I and an X and a negative I and a negative X axis, this is where the square root of -1, which is the same thing as I, must occur. Is this a one or two-dimensional representation? Is it a two-dimensional representation of a one-dimensional idea? No one knows. Actually, some advanced mathematicians probably do know, but I'm not going to get into that.
God knows. I know.
I'm not even going to touch that one. Okay. In terms of manipulation of these numbers, okay, a complex number has a real and an unreal component to it. And it's usually of the form A plus B times I. Okay? You can say every number has a real and an unreal component for that matter. For example, the number 5, which would just be out here on the x-axis. How would I write that as a complex number? What is the unreal component of the number 5?
Square root of -25.
Wow. It's actually a simpler question than that. It's not so simple, it's almost a trick question.
Square root of -5.
Nope. If actually you guys are getting wrong answers because you're assuming this is harder than it is, here's all I'm saying.
5i.
5 plus 0i. Okay, 5 plus 0i. The number 5 does not have an unreal component, but if you're asked to write the number 5 in complex form, you would say it's 5 and there's no I component. So that's how you write it. Numbers that are just on the I-axis in the complex plane, I could also, yes?
Are you going to want us to write that?
Not in general, no. When we're done with the complex plane,
Everything you write is like...
it'd be right, but no.
There's 7 plus 0i.
Yeah, for this unit, and sometimes, yes, it says, write the following numbers in complex form, and I throw 5 in there, then yeah. But otherwise, no. As a habit, no, not at all.
You turn off the heat, it's like freezing.
Yeah, turn up the heat. Okay. Similarly, numbers can have no real component and just have an unreal component. Or they can have both. This, incidentally, would represent a number that is only on the I-axis. We won't do a lot with the complex plane right now. We may come back to it. And then you can just have things like 3 minus 2i, which might be 3 over, 2 down. When you are graphing on the complex plane, you treat the real and unreal component the same way you would x comma y. Okay? 3 minus 2i is 3 over on the real axis and 2 down on the imaginary axis. So you graph it as if it were 3 comma -2, but it's not. It's one single number. It's not a length and a width represented by two different numbers. It's one number that represents a two-dimensional position. What's the difference? Not one you'll have to care about until you get to an electrical engineering course. But for now, I'm just telling you, don't confuse them. Addition of complex numbers. Anybody remember this?
Can't you add like terms?
Yeah. Addition of complex numbers.
Like 2i plus 2i is 4i.
Yeah. You add the like terms. So if I say what's 4 plus 2i plus 3 plus 2i.
7 plus 4i.
Sam says 7 plus 4i. Anybody have any issues with that?
No.
No, it's pretty straightforward. Keep track of your negative signs, just like you always do with like terms. So that if I have 4 minus 3i plus negative 2 minus 7i.
Why do you hate?
Why do you hate negative so much, Dean? So what's 4 plus negative 2 give me?
Wait, 4 plus negative
Yeah.
2?
4 plus negative 2 is 2. And what's minus 3i plus negative 7i? Negative 10i in stereo from Saul and Sam. So that's 2 minus 10i. Any issues with addition of complex numbers?
Hell no.
All right. Subtraction of complex numbers. Take a wild guess on how this works.
Subtract like terms.
Subtract like terms. Basically the same way. Once again, keep track of your signs. It's the only thing that can trip you up on this one is if I give you something like negative 10 plus 3i minus 5 minus 2i. So what's negative 10 minus 5?
Negative 5.
Ooh.
Negative 15.
Good save, Saul. And now what is 3i minus negative 2i?
5i.
Plus 5i. Does everyone agree with Saul's enthusiastic answer?
Sure.
Sure? Yes. Subtracting like terms. And we're being careful to distribute the subtraction. So that's why 3i minus negative 2i is how we work that out. We're distributing this act of subtraction here. Okay, here's where it gets a little bit
Weird.
weird. Multiplication. Multiplication. Okay? First thing. I is the square root of negative 1, right?
Yeah.
What is I squared?
Negative 1 square root.
There's a couple things in there, some of which were...
Negative 1.
Yeah, I said it
Isn't
back.
it just negative 1?
Well, it's a square root of negative 1 squared, and when you square square root, they cancel. So I squared is negative 1. It's the only thing we deal with regularly in math that you can square and get a negative as your answer. Squaring always gives a positive unless you're dealing with complex numbers. What then is I cubed?
1.
Well, it's I close. It's I squared times I, right? Okay, and I squared we just said is negative 1, so it's negative 1 times I. So it's negative I.
Which is 1.
Hmm?
Right?
Isn't
Now, I is a square root of negative 1.
Why would
So it's negative.
just leave it at negative I.
It's negative root negative 1, and you can't bring that root into the radical. So it's negative I is how you leave that, but it represents negative square root of negative 1. What is I to the 4th power?
Wouldn't it be end up being negative 1?
Close. Let's try and break it down into something more useful. Can I write it as I squared times I squared?
Yes.
And we said I squared was negative 1, right?
1.
Yeah. So I to the 4th is positive 1.